Hello AP Statistics students. In this video, we are moving on a little bit to sampling distributions for means instead of proportions this time. But I'm hoping this is going to help us coast to the end of this chapter because this is I'm hoping you can see this is exactly the same as proportions with a few differences, but the same general concepts apply. All right, so first, let's take a look at the difference between proportions and means in terms of the kinds of questions that are asked. So a proportion question might be, what proportion of students at Edison did their homework last night? Now, you may not be thinking this way, but that is a categorical variable. Now, it may not be obvious at first, because the answer will be a percent. But what's the question I'm asking people? I'm asking students, did you do your homework? They answer yes or no. That's a categorical variable. Whereas the next question, what is the average GPA of students at Edison? That is a quantitative variable. Because I'm asking students, what is your GPA? They give me a numerical answer that I can take the average of. So the proportion sampling distributions that we've been doing were all categorical variables. And now we're going to do quantitative variables by asking questions like, what is the average GPA? Or what is your GPA? The answers are numbers. They're answers that we can then take the average of. They are quantitative variables. But a lot of the concepts about sampling distributions still apply. So first, let's remind ourselves what a sampling distribution is and what it looks like for means. All right, this was the poop animation. Remember the poop animation? So I'm going to start with a roughly normal distribution here. And then from our population, we sample. Let's take sample sizes of, let's go 15. I think it will do the animation that way. So we're going to take 1. Oh, no, it won't. 10. There we go. So here we are taking a sample from the population, and then we record the average, the mean. And so this distribution of all the sample means is my sampling distribution, right? We keep doing this over and over again, but the data we're recording are the averages. And so when we do that many, many times, we get our sampling distribution, which is the distribution of all the sample means. All right, so that is our sampling distribution. Very similar with proportions, just we're recording a different statistic. All right, shape. So shape, we're going to have to, what is the shape of a sampling distribution of means? Well, it depends. All right, so in order to keep this video short, I'm going to skip shape. We're going to do the shape of these sampling distributions in class next time. If you remember, for proportions, the shape depended on a lot of things. It depended on the proportion. It depended on the sample size. Now, there were certain conditions that if we met them, it would always be normal shape. And there's a similar idea for means, but we're going to get to that in class. Let's do the two easy ones right now, the center and the variability. What is the center of a sampling distribution of a proportion? Thankfully, this is nice and easy. The center of a sampling distribution of sample means is the population mean. So the mean of the sampling distribution is the mean of the population. All right, nice and easy. If I go back to our picture here, as you can see, the mean of our sampling distribution is right in line with the mean of the population. A very similar idea with proportions, but then that one was a bit more complicated actually, Because the mean of the sampling distribution was the population proportion. But that's just because we were interested in proportions. An easier way to connect it is maybe to say, instead of population mean, say population parameter. All right, the center of a sampling distribution should always be the population parameter, whether you're looking at an average or a proportion, whether you're looking at a categorical variable or a quantitative. But the way we could then write that, the mean of all the sample averages, all right, that's how we write the mean of a sampling distribution, mu of x bar. The mean of all the x bars is equal to the mean of the population. All right, now the variability. What is the variability, or the standard deviation of our sampling distribution? Well, here we've got ourselves another equation. So the standard deviation of all the x bars is equal to the square root of the population standard deviation divided by the sample size. The sample size you are taking. Now you might think, oh, Bolt, another equation. How am I going to keep track of? You don't need to keep track of all of these. You just have to be able to Google search the equation sheet by the College Board, okay? You don't actually need to remember these. The hard part is going to be remembering and understanding and identifying which equation to use, okay? So at some point you do want to Google search the equation sheet for AP Statistics, and you got to go through here and find the equation. We are doing, number 3 here, sampling distributions. Yeah, but we're not doing these, we're not doing confidence, we're not doing chi-squared. This will be easier once you know what all of those are. Here we go, sampling distribution for proportions. Here are all our equations from proportions. It's all here, okay? And we want the sampling distribution for means. So you either have it written in your notes or you have a Google search it and get the equation cheat sheet here. And so here we have what we just wrote. The mean of all the x bars is the mean of the population. And the standard, I wrote that wrong, didn't I? The square root is just in the bottom. My bad. The big square root is only for the other one. The standard deviation of all the x bars is the standard deviation divided by the square root of n. It's too early in the morning, isn't it? Boop. There we go. Just the square root of n, which again is why you look it up. I totally planned that. All right, let's keep going. Oh, of course we have to write a sentence, right? In samples of, all right, here you have to put your sample size. We are looking at how far away a sample mean is typically from the population mean. Again, to give you a quick visual there, we've got our sampling distribution, right? And we start putting dots. What do these individual dots in the sampling distribution represent? Each one is a sample mean. All right, it's the average of an entire sample. Now, the standard deviation measures how far away they are from the center, right? How far away, on average, are these dots from the center? But what is the center? Well, we just wrote it right here. The center is the population parameter, the population mean. Oftentimes, we'll use the word true right here, right? The true mean. So how far away your sample means are typically from the population mean. Again, you got to put all that into a sentence. All right, let's practice this. So, been to the movies recently? No. Thanks for reminding me, Bolt. I appreciate it. The number of movies viewed in the last year by students at a large high school has a mean of 19.3 movies with a standard deviation of 15.8 movies. I'm just saying, when you watch the movie at home, the popcorn is a whole lot less expensive, all right? It is real nice to be able to pause that movie, go to the fridge, open it up. It's like, all right, what do I want to snack on right now for this movie? Man. Tell you, sometimes we only get like 5 minutes into the movie before we pause it. All right. Suppose we take an SRS of 100 students from this school and calculate X bar, the mean number of movies viewed by the members of the sample. Okay? So we have this sampling distribution that we're building up. Identify the mean of this sampling distribution. That one should be nice and easy, right? Just the syntax, I think, is the main thing you got to learn here. The mean of all the X bars is equal to the population mean. And so we know the actual population mean here is 19.3. So 19.3 movies. And part B. Calculate and interpret the standard deviation of the sampling distribution. Verify that the 10% condition is met. All right, so let's calculate the standard deviation of all the X bars is equal to, all right, on the top, we've got our standard deviation of the population, which is 15.8 movies, divided by the square root of the sample size, which was 100. Usually I'd type that into the calculator, but that's pretty easy. That's 15.8 divided by 10, which just moves the decimal point over. That is 1.58. All right, a couple of things we got to do here. First, we got to interpret it, so we're going to write our sentence, but we also need to give a nod, a tip of the hat to that 10% condition, okay? The standard deviation is only 1.58 if we were taking if we were sampling with independence. Now, we were not replacing these students. When we pick this student in our sample, we asked them how many movies. We did not put them back into the population. We were sampling without replacement. Now, that usually hurts your independence unless we are sampling less than 10% of the population. So again, we got to give a nod of the hat to that. We are assuming that our SRS of 100 is less than 10% of, now I can't just say population. I have to say what the population is here. And our population is the large high school, right? It's not the US, it's not all high school students in the US. We are just looking at this high school. Is less than 10% of the large high school. Which, that's a fairly fair assumption. That just means we are assuming the high school is more than 1,000 students. Perfectly reasonable. All right, let's now interpret this standard deviation. So, in simple random samples of 100, the sample mean number of movies, how much was the full movies viewed in the last year. The sample mean number of movies watched in the last year. All right, that's our context. That sample mean is typically 1.58 movies away from the true proportion of 19.3 movies. All right, there is our sentence that interprets the standard deviation. That's one thing that you want to be able to write. A few reminders there. The first one, you are talking about sample means. All right, you do need the word sample in there because we're talking about sample means. Away from the true, oops, what am I doing? Proportion is way too early. True proportion. Bolt, come on now. The true mean. Proportions was the previous unit, or the previous section. That's why you always reread your answer. The true mean of 19.3 movies. All right, ladies and gentlemen, right now that's what I want you to be able to do. Identify the sampling distribution center, the mean, and then also the standard deviation with the 10% rule and the interpretive sentence. Good luck with that.